Hello, everyone. Welcome to this session on the importance of data quality in analytics. This is Arun Velu. Good afternoon. I'm based out of Atlanta, East Coast, United States. So, good afternoon, good morning, or good evening to wherever in the world you're joining me from. I'm very glad you chose to join me on this session. So, let's get right into it. This is going to be the agenda for the next 20 minutes, what I'm going to be talking about. Start with a quick introduction about me, and let's talk about why data quality is important, more on the topic of why now, what's at stake. And to ensure data quality, let's talk about what are the components of it and how each of those components interact with our interpretation, our analysis, and let's also talk about what is the cost for us as a business, as a community, as data scientists for not ensuring the quality of data and where we are headed to next, again, as a community of data scientists, where the world is heading to. In the end, I intend to leave a couple of minutes for the questions. Hopefully, we'll have time to do that. So let's get straight into it. That's me. Again, I'm Arun Velu. I'm based out of Atlanta. In case you're wondering what's my authority on talking about the data quality in analytics and modeling, I've spent about 12 years in this space. I started as an analyst with Mu Sigma back in 2009. Mu Sigma is the largest pure play analytics company in the world, based out of Bangalore, India. They employ somewhere between 4,000 to 5,000 modelers and data scientists across the world. They cater to a wide variety of clients. It was an incredible company to start my data career. I moved to United States after that. I know it's not in the chart, but I went to grad school at Duke University. And after that, I joined in 2013 a company called Credigy. It's the consumer finance investment wing of the National Bank of Canada. They buy consumer finance assets mostly from the US banks and lenders and credit organizations and service those assets. I worked within their risk management team. Most of the models that we built got submitted to the Federal Reserve for compliance and certification. So some of the highest elements and standards of data quality were at stake there. Later, I moved to EXL. It's a boutique consulting firm based out of New York, again, catering to a high turnover analytics to a lot of the marketing clients on the East Coast of United States. Spent a relatively shorter time there before I moved to Equifax, where I'm currently working as part of the advanced analytics team. Equifax, again, is a credit bureau, as most of you might know, operates in 27 countries now, one of the owners of the largest data repositories in the world. Again, very high standards of data quality at stake, both in collection and consumption and also in delivery. I think with the big data comes with the big challenges. So more importantly, I'm always willing to be a student of data science and very, very excited to be in this journey of how data is transforming the world. Let's get to why data quality is important. Now, let's start with the game of guessing. I wish we had done this in person in the live audience, but I'll let you all think for a few seconds of how many decisions we are making every day. Think about every day you wake up, make coffee, you commute to work. Maybe not now, but hopefully sometime soon. Spend next 8-9 hours at work. You commute back home. You might play. You're eating 3 meals a day, probably snacking or coffee about a couple of times a day. And maybe you watch, you read, you go back to sleep. So think about how many decisions you're making every day. And so might surprise, shock a lot of you. 35,000. Yeah, 35,000. You're in shock. So did I. It's actually mind-boggling to know that we are making those many decisions. Are we even capable of those decisions? Yes, very much. We do. Just think about how many decisions you've made since the time I started speaking. Now, you made a decision to join, you made a decision to continue, you made a decision to stay up to the third slide. Um, you made a decision whether to check your notification, to mute your inbox, to lean on the table, to lean back, relax, get up, watch TV, play music in parallel. Like you made between 40 to 50 decisions just in the last 3 minutes since I started speaking. Now extrapolate it for the rest of your day. And we're almost there. You can go read in the article, the link is posted down, but 35,000 decisions every day. The important thing is we are recording these decisions more now. We are measuring these decisions now. We have mechanisms and machines to monitor and collect what decisions we make now out of these 35,000. And the way in which the world is increasingly starting to function, a lot of these decisions will not be made by us in the future. Rather, the machines and algorithms and the data mechanisms will make those decisions for us. So, not just companies, not just businesses, not just governments, but we are going to be affected by how these data metrics are being collected, are being recorded, are being consumed, and how good the data is, and how important the quality of the data is, will determine how our lives function very, very soon. So that's is why data quality is very, very important in the current context. Let's talk about quickly what are the components of data quality. Um, I know there are a lot of theories and versions out there in the industry, ranging from how unique data is, am I getting the data on the right time, how consistent the data is the data available to me, is the data available to my audience, is the data available to other data scientists so that they can verify the data. Is the data valid anymore? Is the data old enough? Is the data new enough? How granular is the data? Am I looking at the level of every second? Am I looking at the level of every person, of every transaction? And does the data conform to the different standards where multiple entities are interacting to make those decisions or draw insights out of the data? But all these factors revolve around three anchor components, um, which I list as accuracy, completeness, and relevance. So all the other elements of the data quality revolve around the three fundamental uh, groups. Starting with accuracy, how accurate is the data? It can be answered with a simple question: does the data reflect the reality? That's the simple smell test for to see if the data is accurate enough. Um, where accuracy comes to play is building the trust with our audience. When we present an analysis to the business or to the team or to another company, how accurate is the data will determine whether we make or break the trust with our audience. Next is completeness. For any specific analysis, there uh, are different standards of completeness of the data that can come into play. The easiest question to ask is this data reasonably comprehensive? The term might be oxymoronic, but is the data reasonably comprehensive for me to formulate a hypothesis and verify or invalidate that hypothesis? That's the question that we should be looking for, and it adds into the stability of the analysis. Third, and my favorite one, is the relevance of the data. We're going to be talking about all these three in detail, but relevance is, does this data matter to the analysis? Is it going to impact, and in what way? Those are the questions we should be asking about relevance. And relevance is important because whether we are able to act on the insights, on the results, on the conclusions or reference of an analysis will be determined whether the data that we used for the analysis or model was relevant or not. So that's where that comes into play, and these are the three important components of data quality. Looking them into detail, let's start with accuracy. Um, that's a very unfortunate and a tragic curve chart showing the number of deaths in United States in 2020 between March and December of 2020 uh, due to COVID. So we can see that there are three distinct waves. One that was from April to May, the second one between July and August, and the third one towards the end of the year. Again, very, very unfortunate. If we were to if we were to make an inference out of this, we should conclude that the first wave was more fatal than the second one, and the third one was probably as fatal as the first one. Let's see what happens when we look at the next piece of data. That's the cases for the same time period between March and December of 2020. You can see that the third wave towards the end of the year is very, very steep, followed by the second wave, and which kind of dwarfs the first wave. Very different story from what's happening in deaths versus the cases. If we were to make an inference out of this, we might venture into the wrong path of maybe inferring that the virus, the variant of the virus was much worse in the first wave, or we were underprepared, or it could lead to a lot of misconstrued conclusions until we look at the third piece of data. This is the test. So all three are coming from the COVID tracking project. So this is the number of tests that were done during the same period from March to until the end of the year. If we look at it, towards the end of the year is when we ramped up the testing by a lot, and that is reflective of the number of cases, and that part is accurately reflected in the number of deaths. But what's happening though is the first wave, where we missed the number of cases, but what we did not miss is the deaths, because that will happen anyway, and it's very hard to and it's very hard to run away from that. So that's where we have to focus on how accurate not just the data, but our interpretation of the data is, so that leads to meaningful conclusions, and therefore leads to meaningful actions. Very classic case of how important the data accuracy is, both in terms of the input and also the interpretation. Moving on, talking about the completeness, I'm going to be very quick with this example. This is looking at the intraday performance of the stock called Plains All American Pipeline. If we were to make a stock recommendation based on how it's trending up or downwards, pick a stock, like let's pick this one. It's trending up. So let's say that if it's trending up, we are going to be recommending to buy, and if it's trending down, we are recommending it as not buy. If you're looking at just one day, this is trending up. If you zoom in, look at 1 month, it's down by 7%. So are we going to say don't buy now? If you zoom in 1 more year, it's up by 43%. Again, a recommendation of buy. If you look at 5 years, it's down by 60%. The point I'm trying to make here is how relevant is the length of the data to our analysis. That's where the completeness comes. Is the data reasonably comprehensive for the analysis that I'm making now? If I'm making a stock recommendation, what is the reasonable length of data that I should be looking at? Because the length of the data in our case is actually flipping the decision between buy and not buy. Again, a very important thing to keep in mind. Moving on to relevance, my favorite topic, and going to be starting with a very cliched example of correlation is not causation. This is the correlation curves of the number of words in the National Spelling Bee contest versus the number of people killed by spiders. Again, it's been repeated very often. It's very cliched, but I'm going to be repeating it once again because it demands, it's very important. Correlation is not causation. I repeat, correlation is not causation. The tricky part is the data metrics and attributes that we deal every day are not simple enough, like the academic example that we've picked here. It's not simple enough to belong to universes as different as spelling bee and spiders. So just by looking at it, we know that these two can not be related at all. We're talking about metrics like survival rate and engagement of a subscription model. So it's very hard to, when we look at two curves, like let's assume that these two curves are replaced with survival rate of a subscription model and the customer engagement with the product. And the two curves are looking exactly the same. It's very difficult in that case to know or not know whether they are correlated, I'm sorry, whether they are causing one another, whether the correlation is the effect of the cause and effect relationship. That's very, very tricky. And in our everyday analysis and modeling scenarios, it's not as simple as saying the difference between spelling bee and spiders, but nevertheless, we have to be very careful in dealing with the cause and effect relationships. Taking one more example, I'm going to be very quick here. Let's say we have to make a decision of offering a mortgage product to two people, and US bank is making this offering. Let's say if you look at the credit score, we have to offer this loan to the person with the higher credit score, the person on the right in this case. If we add one more attribute to it, income, the person on the left makes twice the income, and therefore we have to make the offering to him. Now let's add one more of, let's say they're looking at the second lien collateral. In this case, though the score is higher, I'm sorry, though the score is lower, the income is higher. Because of the second lien collateral alone, the scales of the decision will be tipped to the person on the right. Now let's add one more dimension to it. Let's say they both are living in they both are living in Australia. This is a bank that's operating out of the United States. How does the decision matter now? How does any of the metrics that we saw above are still relevant now? They're not. So that's why it's very important to look at what is the relevance of the attributes that we're using. Does this data matter to the analysis? Is a very important question that we have to keep asking and answering. Let's quickly talk about the cost of bad data quality. A lot of studies out there saying that it costs close to $3.1 million. I'm sorry, $3.1 trillion dollars. And then there is a revenue impact of 15 to 30% of the in any business, and about roughly half of the time the data analysts are spending on cleaning the data, which otherwise could be used for other productive means. Again, a chart explaining what are the impact of bad data quality to the businesses, and then I want to focus on the red part, where the vast majority of the businesses are reporting that the bottom line is getting affected by this. Where are we headed next? This shows that not just big companies, but small businesses too. About 75% of the small businesses are inclined towards using artificial intelligence and machine learning, basically data in their operations. More than half of Americans expect cars to be driverless within the next decade. Very important decisions to be made there. Very important data, and the cost of data quality is huge. There are massive cost to that quality of data when we get into driverless cars. Again, the finance world, we are engaging more computers and managing the engine of the world. And more importantly, jobs, about a quarter of jobs are going to be displaced by machines within the next decade. Again, people are listening to data now more than ever. Again, a chart that shows that executives will depend on data more than the people, and it's only going to increase. Um, Again, as I started the talk, with big data comes big responsibility. We as a community, we as a the world, the whole world, along with the data science community, is moving towards a massive explosion of the way in which the data is collected, it's recorded, it's consumed, and made life-changing decisions every day. And therefore the quality of the data in making those decisions is and will be more important as well, more than ever in the future. We better be prepared for it. Thank you. um, I know that I'm on the top of the time limit here. I wanted to give a few minutes for the question and answers. I'll be checking into the breakout room. You're welcome to have any conversation with me. I'll be happy to answer any questions or have a discussion with you. Thank you again for choosing to join me today.